Do 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 do. Dun, 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 dun. All right, so I'm weird. Good morning. This is getting a little bit weird and awkward when it comes to doing classes and talking to yourself. But good morning and welcome, hopefully, to our last math online. And next week, as far as I know, we're back in the class. So next week, Tuesday, I hope to see you in person. And who do we got here joining us? Hey, Ron. Ron, I'm going to be on live stream. It's probably the best to go there unless you have some questions. Then you can talk to me via Zoom here. But since we're all limited, the best place to be to go to the live stream. And the URL is the same here. I'll write it out for you. No problem. Okay, so today, again, I'm not going to be on for 2 hours, although yesterday for biology I was on for a little bit longer than I anticipated. Some of you have been saying that I talk lots. Well, yes, I guess that's true. Today, though, what we're going to be doing is we're going to be reviewing quadratic equations. So we've got trigonometry, and I don't know if that's in the bag or not, but we kind of sort of finished that up, and we're doing some review. If you're not completely finished all the worksheets, then next week we can work on that. We're going to do some more review next week, and we can help with that. Good morning, Charlie. So what we're going to be doing today, again, we're on live stream. What we're going to be doing today is quadratics. And so what I've done is on the live stream in the description there's a link, but the link is I think you figured out my link system by now. bahs.ca/today is January the 13th, and the worksheets that I'm going to be going through, I've got a stack here for 5 or 6 pages, is January 13.1. And again, I'm hoping this is review because what I'm going to be going over are older quizzes and older worksheet assignments. And so I think I've given most of these things to you. You should have a copy yourself there, but if not, then now you have a blank copy, and I'm just going to go over the answers of how to do this stuff to try to give you a heads up on the final exam. These are what I typically do for the final exam is I pull questions from the unit tests and the assignments and put them on the, change some numbers probably, so they're not the exact answers, and then that's what goes on the exam. And I try to do one type of question from each section. And so the going over old assignments and old unit tests is a good review technique. So let's, instead of talking about a whole bunch of these things, let's go through that. And here we are. Okay, so this is a quiz. We'll see how fast or how quickly we can go through this stuff. And I'm going to try to do as many questions as I possibly can, but then I might also give you a little bit of review or something else in between, a little bit of hints and techniques to these things. Okay, so I have my calculator, my handy dandy calculator, and I also have my formula sheet there. Because we're going to be using some of these things specifically. Well, we're going to be using all of them: fractions, patterns, vertex, roots, and vertex. So I'll just put that off to the side and have my calculator right there handy. Okay, so here we go. We're going to just start off with, I think this is page 1. I think they're all in order because I just printed what I gave you. And again, I think you've seen some of these things. So a quadratic equation is a UE graph, and the most important point on the UE graph, or the parabola, is that point right there. Okay, so I'm going to zoom in on this a little bit. And that point, you always go left to right when you're reading. You left to right, and then you go down the page. So you go x first, so this is always x, and then up and down, this is always y. And again, if I'm sounding like I'm repeating myself, and it's not because I think you don't know anything else, but I kind of make the assumption that we're starting from the beginning. Just in case you forget something, then if you hear it 5 times and do it 5 times, then you'll have a more likely chance of remembering what's going on. So I do that intentionally, and it is annoying sometimes. But so this point here, the vertex, and what I do is I put a little v, bracket, and comma, would be at -4 and then up 2, so it'd be -4 and up 2. Okay, I'm going to do the vertex here too. This would be -4 and up 1, so -4 and 1, and I put a v in front. And this v here would be over 2 and up to 3, so over 2 and up 3. Okay. So those are the vertexes, but that's not what I want. It says state the vertex, so I've done that part. And then put it into standard form. Well, standard form is the form which we like. And that's one thing I don't have here, I should have, is my formula sheet. And so you can refer to your formula sheet, but standard form on the formula sheet is the a value in front, the x, actually the x goes in here, and then there's a section out behind. And this part here and this part are the x, goes with the x, and y coordinates. Okay? And then the a value is basically how wide this thing is. Okay? So going from scratch, y is equal to blank, blank, and blank. And I'm going to rewrite over that y, sorry. This is going to be x. This is going to be y is equal to blank, blank, blank. And this is going to be y is equal to blank squared and blank with an x there. Okay, so filling in the numbers, what's going to happen here is I'm going to put in -4, and this is going to be +2. But because this is going in brackets, this -4 is going to be +4 here. These are brackets with an equal sign. These are just coordinates. So when it goes in or out of the brackets, we have to flip it. So it's going into the brackets. So we flip. It was -4. It goes +4. Same thing over here. -4 here, going into the brackets, +4, and then 1 over here, so it'll be +1. And the last one here will be 2, but going into the brackets, -2, and this will be +3. So we're 2/3 of the way. So these things are all worth 3 marks. 3, 3, 3, so 9 marks total for this question. And we've got 2, 4, 6 out of 9 marks. Okay? How do you do the A? Starting from the scratch. From this point, you move over 1 square, and then you count up. How many squares are we counting up or down? So in this case, it's counting, so I move over 1 square. I count up until I hit the blue line. That's 1 square, so it's up by 1. Here, I count over 1 square, and I go down by 1. Down by 1. Here, okay, I'm going to have to zoom in on this one because it's a little bit thin. I go over 1 square, and I go down 1, 2. Down 2. Now we got 9 out of 9. That's it. Okay, word problems, everybody's favorite. Okay, so a small rocket carrying all this stuff, it doesn't really matter. That's the equation. What do you do with a word problem if they give you the equation? Well, you don't think about it. What you do is you quad 3, John Rickett. Okay, so how do you do this? Program down to quad 3, and you go to number 1, and we enter the A, the B, and the C values. The A value, and they actually give you a hint up here, the A value is the number in front of the x squared, the B value is the number in front of the x, and the C value is the other number. Okay, everything's on the left-hand side. So now they're not using x's here, but the a value, there we are, will be negative 16. So negative 16. The b value is in front of the t, or the x, 64, and the c value is 80. Okay, now we could graph it. There's a number of different ways of doing this, but this is the easiest. Now it's going to tell us some answers. So I'm going to write down the answers. First of all, I'm going to write down the answer negative 1 and 5. Okay, those are the roots. So I'm going to put down here off the side, roots, negative 1 and 5. Press enter when finished. And then I'm also going to find the turning point, 5. The turning point is 2 and 144. So the vertex is 2 and 144. And that's all we're looking at. Okay. We also know, okay, so I'm going to hit quit out of here, 7, exit out of here. Clear. We know that this thing is upside down because the a value is negative 16, so it's a big number, so it's super super skinny. Okay, but it's also upside down, so it's going to be kind of like this. We know that the vertex is 2 and 144, so up there. So it goes over 2 squares and then goes up 144 squares. And then we also know that over here it's 5. Okay, so that means if this is the ground here, it starts here, goes up, and then comes down and hits the root at 5. So now let's answer the questions. What is the height of the rocket after 1.5 seconds? Let's skip that question. Okay, what's the maximum height? 144. I skipped A because I want to use these answers. How many seconds later, after it's launched, will the rocket hit the lake? 5 seconds. How did I get those things so quickly? Well, it's that answer and that answer. This is time, that's time, and that's time. So there's 3 times, and they want to know how many seconds, so they want to know time. So it's one of those 3 answers. Now, you can't have a negative time. We haven't invented time machines, so we can't go backwards in time. So that's not the answer ever with a negative root. It's an answer mathematically, but for a word problem, we can't time travel. So this is where it hits the ground, almost always. This is where it reaches its maximum point. Okay, so it takes 2 seconds to reach the maximum height of 144. This is called the maximum or the minimum if it's going down. And so 5 seconds is the answer for that, and that's the answer for that. Now, they're saying, what's the height of the rocket after 1.5 seconds? Well, 1.5 seconds is not the vertex nor one of the roots, so it's a special point. So there's 2 ways of doing this. There's the hard way and the easy way. I don't know which one you'd like to do, but you could type it into y equals, type in the equation of y equals, and then look up 1.5. But looking up 1.5 is a little bit difficult because it's between 1 and 2. The other way of doing it is just they're saying 1.5 seconds, that's a t. So instead of writing t, I can write 1.5. So I'm going to do this down here. And I'm just going to rewrite the question. So it says negative 16t squared. But instead of writing t, I'm going to write 1.5 because that's the t in this particular case. And it's squared. And then moving on, plus 64, I'm going to have 1.5 seconds, plus 80, and that's it. So what I'm going to do is I'm going to figure that out, and I'm going to let the calculator do all the hard work. Now, if there's more than 1 point, if I want you to find 1.5 seconds, 7 seconds, 9 seconds, 20 seconds, if there's a whole bunch, like an Angry Birds question, then you might want to put it into y equals, because then we can see it in table format. But since there's only one point here where we want to figure out, I'm going to do it on the calculator. So here we are, negative 16 bracket 1.5 bracket squared plus 64 bracket 1.5 bracket plus 80. Typing it in, and I get 140. And that's my answer. And it's height. So what are you talking about? Meters? Feet. It says 80 feet, so this would be feet. That's for A, by the way. Okay, so that was a tougher. Word problems are a little bit longer questions. So that was a little bit tougher. Let's do something a little bit more quickly. Okay, I've got a quadratic equation. They want to know the turning point or vertex. Well, how can you find the vertex? We can graph it and go left bound, right bound, or we can John Rick it. And let's John Rick it. It sounds like a verb there, but A value is 3, B value is 6, C value is -1, and so what do they want to know? Turning point. So moving on here, and it actually says turning point. So the turning point, the vertex, is -1, comma, -4. Right there. Moving on. What are the exact roots and simplest forms for this? Now, this isn't written in the right format, so we need everything, all of our quadratics on the left-hand side. So this rewritten really quickly. 2x, I have to bring that 5 over to the other side. So it's +5 now. When I move it to the other side, it's going to be -5, and then there'll be 0 on that side. Okay? So there's my 1, 2, 3. Right? I had to move it over. But now that we have that, we know that A is equal to 1, B is equal to 2, and C is equal to -5. Whenever they say exact roots, they want you to use the quadratic formula. Well, the quadratic formula is the John Rick thing. Okay, so we're shortcutting the system here a little bit. So 1, 2, -5, and they say, John Rick actually says, and you can't see it, sorry, you can't see that. John Rick actually says here that, this doesn't work out evenly. So you're going to have to use the quadratic formula, which is -b plus or minus. That whole formula is on your formula sheet, so you don't have to memorize it at all. You can just copy it down. And so that's what I'm going to do. I'm going to copy, as soon as I see that on John Rick, and I see the exact roots, I'm basically going to say, well, x, which are the roots, is -b. I'm going to copy that formula down, plus or minus square root of b squared, excuse me, minus 4ac all over 2a. And then I'm just going to copy my b value, -2, plus or minus square root 2 squared. So I'm not really doing any math. I'm just transcribing 1, -5, divided by 2 times 1. And then, what have I done? No math. There's my answer. -1 plus or minus root 6. -1 plus or minus root 6. It's basically a bunch of calculator punching at this point. Again, we're doing these things really quickly. And so we're using the calculator to our advantage in this case. Okay? And that's it. Moving on. Patterns. How do you do patterns? Using regression. Oh, they give you a hint. Using regression. So, this is the first, this is the second, this is the third, and this is the fourth. Okay? So how do you do patterns? Well, if you forgot how to do patterns, then let me remind you. Patterns. And they've got 3 different patterns. Hit Stat, and then Edit, and put your X and Y values into L1 and L2. And then go Stat, scroll over to Calculate, and go to Quadrag. And that's your equation. Okay. So let's get out of John Rick. Stat, there's Edit. Oh, there's L1 and L2. Okay. So I'm going to put 1, 2, 3, 4. And then over here, I'm going to put, there's 1 square, then there's 3 squares, and then there's 1, 2, 3, 4, 5, 6. And then there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then, according to the instructions, Stat, scroll over to Calculate, and down to Quadrag. Now, if it's a quadratic, we go to Quadrag. If it's linear, which we did linears, then you go to LinReg. If it's exponential, which we didn't do, you go down to exponential reg. Quadrag. We want to make sure that r squared is equal 1. That means we did it right. If r squared is not 1, then it doesn't work out. So you either entered a number in wrong, or it's not a quadratic equation. So that's our double check. We know it's perfect. So the answer is, the A is 0.5. So I'm going to bring it off to the side here. Y is equal to 0.5x squared plus 0.5x plus 0. The C value happens to be 0. And then just because I used linear regression, I'm going to put r squared equals 1. That symbolizes to me that I know what I'm doing, and you know what you're doing, and that we use the linear regression there. Okay. Now, we have an equation. They want to know the 29th. Okay, so if we were to draw 1, 2, 3, 4, draw the 5th one here, all we're going to do is we're going to add, we can draw the 5th one, no problem. Okay, and so I can figure that out. There's 10 here, so there's 10, 11, 12, 13, 14, 15. So the next one would be 15 probably, and then add another one, and add another one, and we could figure that thing out logically, but it'd take a lot of paper to draw that, especially when the 29th. The easier way is the same way we did the previous one right here. Where did that one go? After 1.5 seconds, 4a. Okay, we have the equation, so then all we need to do is substitute one number in. In this case, we want the 29th number. So I'm going to write down the equation, 0.5 x squared, but the x in this case is going to be 29. And then I'm going to do the same thing here, 0.5, that's a 0.5, and I'm going to put the x in, and my x is 29, plus 0. And the math part, I'm not going to even bother with. I'm going to let the calculator do that. 0.5 bracket 29 bracket squared plus 0.5 bracket 29 bracket, and then plus 0, and we get 435. Now this is a really good question, right? Because I can, and you will see one of these things on the final exam. Okay, why? Because it's really easy to change the question. I can put 31 there, and the question's changed. Or I can do something like this. Matter of fact, this is the reason I print this thing off. This wasn't in a worksheet. You've got the thing, the question. But, I could give you any of these things. So doing the same thing here. This is number 1, number 2, number 3. Okay, 1, 2, 3, 4, 5. So there's 5 there. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17 there. Okay, what's the equation for that? Stat, edit, 1, 2, 3. I already got 1, 2, 3. And over here, I'm starting off with 5, and then 10, and then 17. I don't know if this is going to work, but I don't have to worry about that because the calculator will tell me if it's going to work. It does. 1, 2, 2, r squared equals 1. In other words, and I'm going to put it down, a is equal to 1, b is equal to 2, and c is equal to 2. In other words, y is equal to 1x squared plus 2x plus 2. And I'm going to put r squared equals 1, just so that that's how I got it. Now, if I want to know the 29th object for that particular thing, then I would substitute instead, I type in the calculator 1, and then put a bracket, put in 29 squared, just like it did before. So, clear, 1 bracket 29 bracket squared. That would be a really difficult one to draw, the 29th object, right? Plus 2 bracket 29 bracket plus 2. So that's the same thing. Instead of writing x, I wrote things in brackets, squared, squared. And I'm going to get 901. That would be 29th. It's 901. That would be a lot of squares. You'd be there for a long time. And by the way, don't do that. Right? I don't want you drawing squares for like 2 hours on a final exam or anything else. That's not the intent. It didn't take us 2 hours, right? I don't want you drawing little squares, right? If you're asking for paper and I see you fill up with squares, I'm going to say no, skip that question. All right, moving on. We'll put that away. Use that for scrap. How do you graph something? Well, the most important point is the vertex. And so this vertex, you're pulling the number out. It'd be -1 and -2. And then it's going to be skinny because that's 2. So -1 and -2 down here. There's my most important point. I should put that in red. And that's the vertex. We know it's positive. It opens up. So I'm going to move over 1 square. And then I'm going to go up 2. Okay, so I'm going to put a is equal to +2. Let me put it that way. This one's all messed up. Okay, over 1, up 1, 2 on the one side, and over 1 the other way, and up 2 the other side. And there's my graph. Okay, try not to make it a V so much. That's not pointy down there. It is a nice curve there, but I realize we're not all professional artists. What's the deal with this? The deal with this is that it's a math teacher question, and they've written it in, this is called transformational form. Not that you need to know that, but you do need to know how to put it into normal form. And so we want y by itself, so we have to get rid of this thing here. The way you get rid of this is the a 1 over a. Again, we've done this in class, so you need to put it in here. Y equals blank, bracket, bracket squared, and then blank. Okay, and the x goes in there. Now, the x part doesn't change. So x minus 1, x minus 1. Okay, and the way to think of this is the most important part is the vertex. And the way that some math teachers out there justify having this format is that, well, listen, the x goes with the x and the y goes with the y. Oh, well, x here would be, so the vertex would be positive 1, comma, and then we don't know the next one. The x goes with the x. When we pull the x number out, it's positive 1. Well, the y goes with the y. So when we pull that out, it's in brackets now. So when we pull it over here, it'll be negative 4. And that might be an easy way of remembering, oh, negative 4. So then this thing's going to be negative 4. Okay? The other thing to note is that the a value here, and if you take a look at your formula sheet, you can see that this is, it actually says 1 over a on your formula sheet. So that 1 over a, if this is it, that means that's a. That's the number in front. Okay? So transformational form is a little bit tricky there because we convert it to the regular form. Now that we have the regular form, all we do is we find positive 1, negative 4, positive 1, negative 4. Right there, that's my vertex, that's my most important point. And from that point, I'm going to go over 1, up 1, 2, over 1 the other way, up 2, and there we are, we have another graph. Again, try not to make it too pointy at the bottom there. It's a nice rounded bottom. Oh my goodness. There we are. Height of your roots, quad 3. Okay, really quickly, let's do some questions quick. Program, quad 3. We did a whole 50 questions or something on this thing, and hopefully you figured out by then that using this John Rick program is pretty darn easy. The two roots are 8 and negative 2. 8 and negative 2. Next question, another quad. So my a value is 3, my b value is negative 12, my c value is negative 36. 3, negative 12, negative 36. 6 and negative 2. Okay. Another way of doing this, okay, if you factor it, there it is, 6 and 2. And because they're in brackets, when you pull it out, negative 6 becomes positive 6, and positive 2 becomes negative 2. So you can pull them out of brackets. Another way of figuring this thing out, okay, so there's more than one way of doing this thing, is to graph it. Okay, if I were to graph this one here, now you can't see the bottom, okay, but we don't really want to see the bottom. Why? Not for roots. Roots is when it crosses the x line. So pulling this thing down, it goes down, and then it goes down way down here, and the vertex is down here somewhere, and then it goes back up. Well, we want to know where it crosses the x. So guess what that number is? That's 0, 0. That's negative 1, negative 2. Oh, negative 2. And this one number over here is 6. So if you graph it and then figure out where the x line is, it will show you there on the graph where they are. So another way of doing it. Oh, look at this. Hint. Roots can be found by factoring. Okay. Quad 3, graphing, left to right bound, and quad equation. So there's a whole bunch of different ways of doing this. The way of doing this, okay, and we did this in class too, is bracket, 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 x, x. What two numbers multiply to give you 16, add to give you negative 6. Okay, multiply to give you negative 16. Well, 8 and 2, 8 times 2 is 16, and if we make the 8 negative, negative 8 plus positive 2 is negative 6. And so there it is factored, there it is factored. And again, when you pull the numbers out, negative 8 turns to positive 8, and positive 2 turns to negative 2. Okay, we could have done this one too, but there's a number in front, so it's harder to do it that way. So you can graph it, you can do it the other way. And I think that was it for that particular, they call that a quiz. All right. Okay, so I'm maybe not going to go in the same, here, let's do this one again. Okay, so this is the same type of thing. We're factoring it. What two numbers multiply give me negative 15, add to give me 14? Well, in this case it's B, so B and B, well, I'm thinking 15 times 1. Okay, so negative 1 and 15 will give you negative 15, and negative 1 plus 15 gives you negative 14. So what are the B values? Well, they're coming out of brackets, so this would be positive 1 for this case, and negative 15 are my two answers. That was easy. And this question I think we just did we not? Is the same question as on the other sheet. So this would be negative 8 and positive 2. And so my answers are positive 8 and negative 2. They're coming out of brackets. Graph the two equations. Okay, this is in weird format. Are these the same questions? Look at that. Same question. And same question. So I'm not going to do that one again. Why would I give you the same thing on a quiz as I would on an assignment? Well, because I don't want to invent another question, and I want to make sure that you understand what you're doing. So when you do assignments, you do them at home, hopefully on your own, but maybe not. When you do quizzes, you're in class, and hopefully you know what you're doing on your own. And what does that mean about the final exam? Are they going to be the same questions? Maybe not, right? All I need to do is change that 2 to a 3, and the answer is different. And change this 1 to a 2, and the answer is different. But the questions are the same type of question, and the graph is going to be more or less the same. So can you expect something like this or something like that on the final exam? Yes. Okay, so that's why we're doing this. These are a really, really good review because it shows you whether you know what you're doing or not. I'm not going to do it again, no, because we just finished doing that. Okay, moving on. If I have the maximum of 13, this point here is 13 high. Okay, so that means the vertex, the second number is 13. It's an Angry Birds question, but it's just a really short one. Well, what is the x value? Well, the x value is the halfway point between the up and the down. That's a root, and that will be a root. Okay, because that's where it hits the ground. Halfway between 0 and 26 is another 13. So it's a different 13. This is 13 high, and this is 13 along here. It just happens to be 13, 13. But when you get to that, because it's the vertex, that's the most important point, so I can put 13, 13 in here. Lucky number 13 for Bluebird. Okay, now this is positive 13 and this is positive 13, but because we're putting it into brackets, this will be negative 13. And the only thing I don't know is, what's my A value? Now the A value is rather difficult to find in this case. We do know it's negative because it's upside down, but what is that number? That's the part of the question there. That's why we did a whole bunch of Angry Birds questions. So you can probably figure this thing out and this thing out on your own, just because, oh, the vertex, it's easy. That's the quick and dirty method. But figuring out the A, you're going to need your calculator. And specifically, we're going to have to do regression. Regression. Going back in time to figure it out. So what do we need for regression? Well, regression is just like patterns. And we've already done 2 or 3 patterns here today. So I'm just going to, let's figure out this pattern here. So I'm going to write a table. I'm going to put X and Y in here. And again, I'm hoping this is all review. But it's been a long time since we've done these little Angry Bird things. So this Angry Bird starts off at 0, 0. He hits a vertex at 13, 13, and then he finally hits the ground here again and goes poof and a bunch of feathers at it's 26 goes first, and then he's at 0 height. This is height, this is the width. And I'm hoping this will, oh yeah, I remember what to do now. We've got 2, 2, and 2. We've got a pattern here of numbers. And when we have a pattern of numbers, we put it into stat, edit, and we do the quadratic regression. So let's do this really quickly. Get out of that. What's going on here? All right, turn it off, turn it on. Clear. Okay, stat, edit, 1, 2, 3. I don't want 1, 2, 3. I want 0, 13, and 26. You can't see that. And then over here, I want 0, 0, 13, 13, and 26, 0. I've entered my numbers in. Stat, scroll over down here, go down to quadratic regression. R squared equals 1. And that's why, look at that weird number. That's why we needed the calculator to help us figure it out. Because the A value is negative, which we knew it was because it's upside down, but it's some weird number. 0.076923. So A is equal to negative 0. What did I say? 0.7692300769. Okay, now do you need to write all those digits? No. Okay, but we had to let the calculator figure that out. We figured out this and this, so we'd have 2/3 of the question, but the last 1 mark is worth a little bit more because you have to punch it in the calculator and let the calculator figure it out. All right, let's talk a little bit more about terminology here. Most important point is this vertex right there. What is that vertex? Well, it looks like it's 1, so I'm going to move it over 1. And it goes up by 4, so the vertex is 1, 4. So writing it in standard form, y is equal to, it's always the same thing with this standard form, isn't it? Okay, when I put these numbers in, it's going to be 1 and 4, positive there, and then it was positive, so I'm going to flip it to negative. And the only other thing I need to know is that A value. Well, the A value, I'm going to move it over from the vertex 1 square, and then I have to go up or down. I have to go down, so it's going to be negative. How many squares do I go down before I hit the quadratic line? 1. Down 1. There it is. 1, 2, 3, 3 points. Okay. Now, domain and range. Domain, I don't want you to ever think about it. Okay. Everything we do in Math 12, the domain is, and you can write this, copy it off your formula sheet. X bar X, funky E, funky R, funky bracket. And the Y is the same thing. It's the range, Y bar, Y, funky E, funky R, comma, Y, and then flump, flump. Okay? So range means what values are, if you get an answer, is your answer in the right range. So let's say here that, and the range is where the graph is. So if I'm saying that the y here, it happens to be 4, well, is that possible? Yeah, because that's the vertex. So y being 4 is a valid answer. Now if I say, hey, what happens when y is equal to 5? Now 5 on the graph is right here. Is that a possible answer? No, because the maximum, and that's why they call this the maximum, is 4. And all of a sudden you are giving me an answer 5, which doesn't make sense because that's outside. You can only go up to 4. And you're saying go up to 5. That's not possible. So that's what this is saying. What's the maximum possible number? Well, the answer is 4. It's always going to be that max or minimum right there. And so we want a little Pac-Man here to eat the biggest number possible. So it's going to eat, maximums always open to the left for the Pac-Man. Minimums, and you can write that down on your formula sheet, always the Pac-Man always goes to the right. So max, you write it as that, and min, you write it like that every time. Okay? However you want to look at that. Another way, in the past, one of my students said, all you do is you take your parabola and you pretend it's the Pac-Man and you rotate it counterclockwise by 1. What do you mean not? Like you rotate it left. So that's the way the Pac-Man goes. So if the U or the parabola is upside down and you rotate it that way, that's the way the Pac-Man goes. If the parabola is right side up, like this, you still rotate it that way, and then Pac-Man goes the opposite direction. So I don't know, whichever way you want to do it. Okay, write it down on your formula sheet though, so that is one less thing you have to remember. Okay, transformational form, the mapping rule. Basically, you're looking at, just another way of putting it in, this is your x of your vertex, and this is the y of your vertex. Okay? And then the number in front of the y is upside down or not. So let's just figure out what's the find the most important point. Right? So even if you get this all wrong, if you find the vertex, then I might have pity on you. And, okay, so there's 0, 1, 2, that's -3, so it's -3. The vertex is -3 and 2. So I'm looking for in front of the x, with the x is a -3, and with the y I want +2. So -3, -2, -3, +2 is right there. That's 1. And that's it right there. There's only -3, +2, -3, +2. Okay. Pattern, we're not going to do another pattern, but you do 1, 2, 3, 5, 8. Is there 8 there? 5, 8. And there's 9, 10, 11, 12, 13. And you write in there r squared equals 1. And then determine the 29. Oh, it's 29 again. All I did is I swapped out that picture. Here's 3 more questions that I could use. Here's a pattern. 1, 2, 3. 3. You count the squares. Stick it in. Quad reg. R squared has to be equal to 1. And then you figure it out. Same thing here. This is the first number, the second number, the third number, the fourth number, the fifth number. Okay, now you have a table. Okay, this is the x, this is the y, or L1, L2. You put it in there, and you can predict what the next ones are. By in this case, I would you'd figure out the equation. So let's say the equation ends up at y is equal to 2x squared plus 3. I don't know what it is. Plus 5, and we got r squared equals 1. You got that pattern, but now you have to predict the next 3 in that pattern. Well, what I would do is I would take this equation here, and I want to find the first, second, third, fourth, fifth. I want to find the 6th, 7th, and 8th. So I could put in 6, figure out that answer, and then put in 7 here for x and figure out that answer, and put in 8 and figure out that answer. Or, to make it nice and simple, all I need to do is put in 2x squared plus 3x plus 5, if that were the equation, which it's not likely, okay, because I'm just guessing at that. I just some random numbers, and then the first number here, second, I want to go down to this. What did I say? The 5th, 6th, and 7th. So I'd write down 70, 95, and 124 in the blanks. Now I know this isn't the right case because my first number should say -1, and my first number says 10. So this equation that I punched in is not that equation, not that answer. But then I didn't actually do quad reg on that either. All right. This is getting to be a little bit repetitive. Oh, look at this. Look at this. Have we seen these questions here somewhere before? Yeah, that's the exact same graphing question as before. So make sure, at the very least, that you know the answers to these 2 questions. There's another mapping rule. Okay, that's the same question. Okay, just on a different assignment or quiz or test. I think this is the unit test, so I took some questions out of there. So we're not going to do that. What else can we do? Here we go. Here's a question that's different. It's a minion question. I don't know. So the cartoon, and this is just me trying to be funny, the cartoons have got absolutely nothing to do with the question. So you don't need to figure out that joke there to get the answer. So that's just, I don't even know what that is. Okay. So we do have a little pattern here, though. And so that's what I'm going to try to figure out. And when they have patterns, it's x and y. I haven't read the question yet, so I don't really know what's going on yet. But this point here is at over 1, up 0, so it'll be 1, 0. This point here will be 2, 1, 2, 1. This will be 3, 4. And this will be 4, 9. So 1, 2, 3, 4. And I don't have any other patterns. Okay, now let's actually, which formula generates the pattern shown on the following graph? Okay, so we have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. I don't really know. Okay, so we could punch these formulas into the calculator as 1, 2, 3, 4 and see which ones match up. Or, since we're getting pretty good at this regression, we could actually take these numbers and then reverse engineer on the calculator and see if it comes up with A is equal to 1, B is equal to 1, C is equal to -2, or which one of these things comes up. And that's the way I'm going to do. So, matter of fact, I'll probably do both. Okay, so first of all, let's graph it. Okay, actually, let's not graph it, because let's get the answer first, so that I only have to graph one. So let's go Stat, Edit, and I've got 1, 2, 3, 4, 1, 2, 3, 4, and I've got 0, 1, 4, 9, 0, 1, 4, 9. Stat, calculate, and it is quadratic, okay, because they're all x squareds, quadratic regression, and it says 1, -2, 1. Okay, so I'm going to write that down. 1, -2, and 1, and I know it's bang on because r squared equals 1. If it's not 1, then I did something wrong. So what does that mean? This happens, this is A, this is B, this is C, and I'll put r squared equals 1. So that means that the answer is y is equal to 1x squared minus 2x plus 1, which is, I don't have to write down the ones. Well, I don't have to write down that one. That one I do. So it's C right there, right? 1x squared minus 2x plus 1. Now, here's the thing. So now that we know the answer, the other way of doing it is you could graph each of these four and see which dots line up. So since we know which one it is, I'm going to type that in, x squared minus 2x plus 1 for the red. And then under black here, I'm just skipping a couple here because red and orange look similar. Under the black, I'm going to put in the wrong one, x squared plus x minus 2. You could actually put all four of them in here at the same time. I'm going to hit graph, and there's the one graph, the correct one, and there's the incorrect one. Now, we only want from 0 to 7 and 0 to 10, so I'm going to change my window a little bit and say the 0 to 7 and on the x and 0 to 10 on the y. Now actually you can see what's going on here. So this would be 0, 0, 1. Okay? So they didn't show this dot right here. There's another dot right there, but they didn't show that part. That's okay. If they did show that one, that would give it away right away, because that's your C value. But 1, 1, yeah. Anyways, which one matches up? So 2, 1, 1, 2, 1, 3, 4, 1, 2, 3, 1, 2, 3, 4. Yeah, it's the red line. Okay, the black line's too far up. Okay, that's a good question. How can I change that? Well, it's easily. All I do is I plot the black instead of the red, and so the answer ends up not being C, it ends up being something else. It ends up being, I can't remember which one I punched in. I think it was A I punched in. Okay. One thing we haven't talked about, this is going to be a one-pointer. What is axis of symmetry? Axis of symmetry. Now this should be on your formula sheet, okay? But it tells you in the word, x is. Okay? What's the most important point on a quadratic equation? The vertex. So here's the equation. What's the vertex? Okay? The vertex would be pulling that 3 out. It'd be -3 and -2. And so now let's get straight to the answer. What's the x? What's the most important x? That's the axis of symmetry, the most important one. X is -3. That's your answer. Right? So I know when we went over that in class, it was fuzzy and everything else. But now I'm hoping when looking back and go, are you kidding? Is that all that was with the axis of symmetry? Like it seems, I'm hoping right now the light bulb will come on. That is so simple now, because you've got the general overview. You've got, you're looking at the big picture and looking back at the details. Before you're looking at the details, you didn't see the big picture yet. So I'm hoping that'll be, oh, that's so simple. So the answer is B there, of course. Now, if you, yeah, I'm pretty sure we've done this bird question before too. Okay, height of a falcon. It's doing a dive. The graph shows the height of a falcon as a dove. What's the most important point on this whole graph? That point right there. Okay, so if I were to, use these points to find the equation of the curve of best fit in standard form. So we want to find standard form. In other words, we want y is equal to blank, blank, blank. Okay, actually there's another blank there. And we already know the most important point is 5, 10, so I can fill it in, 5 and 10. And that was positive 5, so I'm going to negative it there, and that's positive 10 because it's in brackets. So I've got 2/3 of the answer there, not even really doing anything. Now, this part here, how do you find the A? This is going to be a little bit more tricky, and we're going to have to use our calculator to figure it out. It's a pattern, and so we've got multiple, 3 at least, coordinates here. This is an Angry Birds question. So you can consider the falcon here angry, because he's a bird too. Charlie, you're supposed to laugh at that. Anyways, this is X, this is Y. I'll put the 5, 10. Do I need the right order? No, not necessarily. This is 0.5 and 91. And this is 10 and 110. 3 numbers. I need a minimum of 3 to find a pattern. And how do you find a pattern? Stat, edit. I'm going to change my numbers. 5, 0.5, and 10. Delete anything else? Yeah, I knew it. There's a 30-second delay on the things, and I knew it. 10, 91, 110. And what do I do next? I'm all a flutter here now. Second function, calculate down here to quadrag.
uh,